Here in this video, we're going to look at section 4.6, solving polynomial equations. The why for this, and we've been talking about it in terms of this chapter, this is our Algebra 2 rite of passage section. And this is where things are going to get the most complicated. It'll later add in synthetic division. We'll use that as like a furthering piece. And a lot of our old solution methods, such as completing the square, quadratic formula, come back as we are solving polynomial equations. In this section, we're going to look at several ways to factor polynomials higher than the second degree, because last chapter we did quadratic. So we could always use the quadratic formula, so on and so forth. And this section is going to include all the different types of factoring that you'll see in Algebra 2. So it brings them all together. There are several new ones, which we'll see on the back side. But the front side is actually just review. So we're going to look at these first ones first. This is the greatest common factors section. And you'll notice that this one is to the fourth power. But all those numbers are divisible by 5. And then also, I'm able to take out a greatest common factor of x squared as well. So once we do that, we are left over with this. And what will really happen most of the time in this section is we'll do something or a different method, greatest common factor, some new ones, and then we'll be left over with a quadratic piece. And we can attempt to factor that from our normal factoring standpoint. For time purposes, I'll let you know that that one does not factor. And if you tried it with 2x and x, and then your different factors of 10, you would recognize that there are no combinations that work, and that'll happen sometimes this chapter. That just means we need to use the quadratic formula. So here's another one with greatest common factor. You might recognize that they're all divisible by 2, and they all have an x that they can also give. So here we get x squared minus 5x plus 6. Now this one does factor further, where we have x and x. Then I need numbers that multiply to negative 6, that add to negative 5, and that would be negative 2 and negative 3. So this is now fully factored. And later on in this section we'll talk about solving, which this one was just an expression because there's no equal sign. But we would use the zero product property to set up those different pieces equal to 0 to find our x-intercepts. So that's a review of factoring with greatest common factors. Here's one where we're factoring where a is not 1. And remember for this has two different possible starts. This could be 3x and 2x. This could also be 6x and x, because both of those multiply together to give me a 6x squared. And there's no GCF on this one, so we're stuck factoring from the standpoint of when a is not 1. So what we're looking for is factors of 10, which are 1 times 10, 2 times 5. And we're looking for the right combinations so that when we put it in place with the 3 and the 2, or the 6 and the 1, that it foils out to give us the 11x. Remember, when we're factoring where a is not 1, these factors will no longer add up to the 11. And it's very tempting for this one because 1 and 10 does add up to 11. But whenever a isn't 1 and you have numbers here, remember that your factors will not add up to the number in the middle. We have to get that from FOIL. Now, when you try the different combinations and you FOIL them out, eventually you would land at trying negative 2 here, a positive 5 here. And when you FOIL this out, we get a 6x squared, a plus 15x, a minus 4x, and you can see that these two combine together to give me that 11, and then the negative 2 times the 5 is a negative 10. So that confirms for us that that is the correct factorization. So that was some of the factoring we did. It's the kind that you all didn't like, because a wasn't 1, but those will stick around here for us too. We looked at perfect trinomials, and we could identify those by perfect squares. And it wasn't a guarantee that this would happen, but it was a good thing to recognize that if your A and C terms were perfect squares, to check to see if you had a perfect trinomial. And this one works because 4 plus 4 is 8, 4 times 4 is 16. And on these, we condensed it down to x plus 4 squared. And that will mean more to us this chapter to do that. So this one here, x minus 5, which would give us x minus 5 squared. Then we realized that not all polynomials had real solutions. Some were imaginary. Imaginary numbers do come back to us here in this chapter. And so it wants to know what are the real or imaginary solutions to these equations here. And this is essentially the full force 4.6 style of question. Now, hopefully you recall that if I'm going to do any type of factoring or work on polynomial pieces, you do want to be set up equal to 0. So the first step is to subtract 3 from both sides, 3x from both sides. We have a GCF on this one of x. And it leaves us with 2x squared minus 5x minus 3. Okay. Now, in terms of finding our solutions, this one, when we use the zero product property, it's equal to 0. That's one of our solutions. If you graph this equation, you'll see that it crosses over at 0. And for this piece, we could try to factor it, because it may or may not factor, or we could also use the quadratic formula. And remember that you can use the quadratic formula if you're stumped on factoring. This one does factor to 2x and x plus 1 and minus 3. And if you spent the time with it separate from this video, you'd be able to confirm that. I'm just filling it in here for us because that's something from last chapter, and I'm just trying to help us understand this new concept of finding solutions when we're bigger than a quadratic in terms of degree. These ones now, you set up both pieces equal to 0 and solve. So this one gives us x is equal to 3. This one, when I subtract 1 and then divide by 2, we get negative 1/2. So if you were to graph this polynomial, you would see that it has all 3 of those x-intercepts. So this one ended up having all real solutions. Let's check this second one out. First step is to make sure that we're equal to 0. So I've subtracted the 6x cubed from both sides. And now we'll look for a GCF, and we have one of 3x squared all right, and we're left over with this here. Now, if we go to set up 3x squared is equal to 0, divide both sides by 3, take the square root of both sides, which normally involves us using a plus or minus, but 0 doesn't have a plus or minus. We now have this piece. And if you look at it, you can hopefully see right away that it is not factorable. There are no factors of 2, of positive 2, that will add together to give me a negative 1, which means we have a couple options. 2, in fact. We have completing the square, or we have quadratic formula. I wouldn't recommend completing the square on this one because your b value is odd. And when we do b divided by 2 squared, it's going to give us some fractions. So I would then fire up the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we'll simplify this and find out what our other two x-intercepts are. So here we'll have a 1 plus or minus 1 minus 8 over 2. So we'll get a 1 plus or minus square root of negative 7 over 2. And then for this one's final answer here, all we'll have to do is recognize that if there's a negative underneath the square root, we move it out as I. And there we go. So there's two more solutions. So this one had solutions of 0. If you graph this, you would see that it crossed over at 0, the x-axis, but you would not see these because they're imaginary. They exist on paper only. All right. So we'll use the quadratic formula a fair amount still as we move through this chapter. And then the last type of factoring that will be review here for us is difference of squares. And that's where it ended up being a plus b, a minus b. These are the ones that I could give you 100 of, and you'd be able to do them very quickly. All right, because there's no b term, so you know it has to be plus and minus. This third one here, where you take the square root of both terms of your a and b, you'd get 3x plus 10 and 3x minus 10. And then you might be wondering, what's going on with this one here in the middle? There's no GCF, so that doesn't fix the fact that 13 isn't a perfect square. What you can do on this is follow the same pattern. So the square root of 4x squared is 2x and 2x. The square root of 13, with the plus and the minus, is square root of 13. And that's a fast way to get ones like that factored. Now it has a square root in there, but if you FOIL it out, you'll get 4x squared minus 2 square root of 13. Sorry, just 2x square root of 13 plus 2x square root of 13. And then square root of 13 times negative square root of 13 gives us negative 13. These middle terms cancel. We're right back to where we were. So we won't typically see ones like that, but I did want to get you prepared for, what it might look like if one of those numbers is not a perfect square, but you still wanted to factor it using the difference of squares.